Here's integrated 3. It's problem 1-21. It says factor each expression completely. So I hope that you are familiar with factoring and on factoring. Factoring with a quadratic, you're usually going to get these two binomials. So if you have x squared minus something x minus something, squared term, an x term, and a constant term, then you're going to try to use what we call this diamond problem. So you get the coefficient of the x squared and you multiply it by the constant, so 1 times negative 72, and that goes in the top really small. I can write bigger next time. And then you take the coefficient of x squared, or sorry, of x, and you write it down here. I'm looking for something that multiplies to make negative 72, and it adds to make negative 1. And then so I think of all the ways I can multiply to make 72. Like, the first thing that comes to my mind is 9 times 8. Actually, 9 times 8 is the answer, because I can take negative 9 times positive 8, and it gives me negative 72. Negative 9 plus positive 8 gives me negative 1. Now, I could get out my area model box and put these all inside it, but since there's only a 1 here in front of my x squared term, I know it's just going to be this. Okay, so this is actually the factored answer. Factored means even though there's plus signs in it, it means there's something multiplied against something else. This is saying x minus 9 times x plus 8. This is considered factored down here. Up here we have just add-ins. Things are being added together, but down here is factored. So the directions told us to factor completely. This one looks like a quadratic. I guess I could put a plus 0 on it, but I think if with a little experience, the easiest thing to do is to look at your terms and see if you can factor out a greatest common factor. So I see that these are both divisible by 6 and x. And then so what would go inside here? 6x times something is 6x squared. 6x times x. And then take a wild guess what could go in here. 6x times something is 48. I heard I think it was one of you, explaining it to your classmate, and the way I heard it explained was you're dividing. It's like you're dividing these by 6x, and that's where you get the x plus 8. You're factoring, not dividing, but you can think of it as dividing if that helps you. Okay, so this is factored completely, because I do have factors. This is x plus 8. This one is in the regular standard quadratic form. It's got there's an invisible 1 in front of my x squared. It's got an x squared and an x and a constant term. So I'm going to try to factor it like this. Since there's a 1 here, with my x, I know it's going to be kind of like that. It's going to multiply 1 times 16. It's going to multiply to 16 and add to make negative 8. I'll write my multiply add. So what can multiply to 16? 8 times 2 is 16, but that doesn't work. 4 times 4 is 16. So, hey, I should have noticed that this is going to be a perfect square trinomial. I didn't notice it, but a negative times a negative is a positive. Okay, so it's this. But I can write this. I don't have to just leave it as this. I can write it like this. And I can say, why didn't I notice, if you have a perfect square and another perfect square, and the middle term is, how do they do that? Is half of this perfect square. I think you have a perfect square trinomial. But if you don't notice and you just do it this way, it's okay. It'll still work. This one is a difference of squares. I have a perfect square and another perfect square. And so this is like, I don't know if you've seen this before. Let's not use x, a squared minus b squared. That's how they usually show it. Turns out like this. That's called difference of squares. And so I recognize this as a difference of squares. So I don't even do the hard work of a diamond problem. I know it's a difference of squares. If that doesn't make sense because you don't remember studying difference of squares, you can imagine something that multiplies to make negative 49 and adds to make 0. Well, we know it's 7 times 7 makes 40. Oh, sorry. Would it be positive 49? No, it's negative 49. So 7 times, oh, there we go. So negative 7 times negative, or times positive 7 is negative 49. If I add them, they make 0. And so I don't know if this helps you at all, but I'm just showing why this works. I never do this. I just look at it and I know it's a difference of squares because it follows this pattern. But if you did want to go through all this, you would find the answer, because this would be negative 7x and this would be 7x, and then you'd have right, this times this equals this times this equals this times this equals this. Okay, so but it's called a difference of squares.